Okay, we're going to get started. Most exciting session of the entire conference, the security session. We have three very interesting talks. The first talk in the security session is for database-backed applications. Other authors are Travis Hans, Thomas Austin, Kong. Go ahead.
Hi. All right, cool. So I'm about preventing leaks and database-backed. But we're going to start by talking about a different kind of leak. This picture is a spill of 1989. What happened was the Exxon Valdez tanker and disasters of the 20th century. The factor behind the severity of the crash was that there was only a sail from the sea. Afterward, the required that all tankers have double hulls, where there's a layer of separating the oil from everything else. This change has prevented numerous spills. Does this have to do with information leaks? Well, the goal of information is to build a double hull equivalent for data, but it's a little bit more complicated than crude oil. Language-based security is based on looking at designs for, and some of these double hulls are difficult is to make double hulls that are as easy to construct. So this talk is about making it easier to secure web programs. Why it's hard to prevent information leaks. And then also that makes writing secure web programs easier. How we support this programming model in database-backed. All right, let's start by why it's hard. Let's say we have a social calendar, much more sharing and searching capabilities, and I want to plan a surprise paper discussion for Emery to thank him for being such a good PC chair. And especially if you were on the PC, you notice that Emery really likes discussing papers. So we thought this would be the best thing for him. But the first is we want to make sure that only people who can see party and everybody else doesn't have this information. So we want the guests to be able to see that there's a surprise party at Chuck E. Cheese. Clearly, Arjun and I aren't very familiar with the greater Santa. Emery should be able to see that he has pizza plans, not that it's a surprise paper discussion, which would be his. Everybody else, including the celebrating otters, at Chuck E. Cheese, because it is, after all, a public space, and they should know not to go there at the time because they're going to have to discuss paper. So now I'll describe what can get complicated with enforcing policies. So first of all, policies might depend on sensitive values. If you've shared a calendar with anybody, you've probably had the experience of events showing up on your calendar. Prize paper discussion showing up on the calendar of anyone who. First, we want a policy on the event. You have to see the event information. But this is a really. So the guest list actually allows hosts to play around with finalized. So we have this additional box, has a list, and that has its own policy. You have to. The list has to be finalized for you to be able to see the list. So now it becomes dangerous. Depends on the policy for the sensitive guest list. Key enforcement, which is when the programmer neglects dependent sensitive values. And to so let's say, well, let's pretend this is that. To the non-final guest list, because he is my PhD advisor. Armando sees the event on his calendar. So Then we somehow run out of room because we don't have a of Armando. Armando is not on the finalized list, invited because there had been a party that showed up on his list. Here was that the implementation for the event policy, the guest list policy, and you might say, well, this is with a weird party, but this actually arises whenever programmers are. So this pattern of bug has shown up numerous times. And when I worked at Facebook, I discovered that the reason why you can always stalk people on Facebook is because programmers are always forgetting policies like this. The first dangerous thing was policies can depend on other policies, but now programmers across the code. So but again, this is a fancy calendar, so we might have searches, like what is the most popular location among my friends at 7 p.m. on Tuesday. A big source of information leaks because programmers often forget the actual events are or the actual locations are Chuck E. Cheese, most popular location, and often the not just to single users, but they're being broadcast to us. So now the programmer has to track values, but also where these derived values are. And if you still don't believe me that this can be a real mess, code from the hot crap conference management system, and every line of code, but what I want to show are the highlighted. So these are if and else checks that check properties of the view state, and then they show different values based on the side. They're actually dynamically generated SQL queries to the data. Talk about later why this is even more problematic. Here is that to implement any policy or any new function, about the spaghetti of policy and other code all the way. Just 2 files here, but in at least 24 of the 81 permissions checks. And the thing is, with existing a lot of verification, but the programmer still has to write these checks about what it means to be a leak. Our work can come in and fix everything. And the programming model of Jacqueline from the rest of the code. You specify them alongside. Programs run in an enhanced runtime that prevents information. And the enhanced runtime includes both preventing leaks between the two. Very important. But a policy-agnostic programming model for a database. So the idea is you can factor out policies, the rest of the code is. We present semantics and proofs for policy. Lets you interact with vanilla unmodified SQL databases. And we also demonstrate practical feasibility on web framework and application case studies. Let's start by looking at the architecture of what it looks like to program in Jacqueline. This is a standard architecture. This is no Jacqueline yet. But in a standard model view controller framework, you describes how the data is laid out. You have the views that describes how the front ends are laid out, and you have the controller. In Jacqueline, the programmer specifies policy of the model. The controller runs in an enhanced policies aren't leaking. The framework is responsible for attaching policies based on it. There's an object related and sensitive values through all computations. So object uniform object representation between an application and database. Object representation that's enhanced with information. And then the framework shows the appropriate on the viewer and the policies. To make this concrete, let's look at what it looks like We've implemented a Python web framework. We extend the Django web. Writing code in Jacqueline looks as similar. So the event class for a calendar example. Exactly what you write in Django. Sensitive. How we do this? Method that says what the actual location field. So returning the string undisclosed. Now we want to know when we it takes two arguments, the event, which is the current can see the location if they're a host, a guest of the event. It's just regular Django, Jacqueline. The additional property that everything is running and our sure that these additional policy queries aren't leaky. All right, so this is all you really have to write to implement. Here are a few screenshots of the calendar example in Jacqueline. And again, I don't show, are the policies are centralized? Oh, you can't really see the highlight with the model. And the rest of the program is you can write view code, you can write controller code, you don't need explicit declaration code, you can arbitrarily scale it without writing any policy. Is responsible for enforcing the policies and showing the appropriate values. About this runtime, how does it actually work? Jeeves programming language, which we've designed to be a policy running with faceted execution, which is for sensitive values. And this is what I mean. Can have what we call multiple facets. This is a location secret or high confidentiality facet that corresponds to the actual. There's this alternate public or low confidentiality you can see if you can't see the secret facet. So here we have, and you can use this value interchangeably. So we can use it in a program that starts by setting a, if our secret location is equal to Chuck E. Cheese, we increase the user count. You can imagine a more complex version of this is used to count. So what Jeeves does is the policies to make sure that they're showing values based on the policies and the viewer. So they can see the secret location, so they can see the incremented value of user still 0. And it has what we call an implicit flow. You might notice that we're location value directly, but we're doing a computation and that. And how by using labels to track sensitive values through. So the location actually has follows the value as it becomes a label is used to keep track of the assumptions that were made in order to captures that label and updating the value C will count users. Make sure that Emory can't see not just the sensitive event information based on that. We have really nice guarantees, and so like we stay within the Jeeves runtime, just like life is great, double-hauled ships. But with oil, It has to come from somewhere before it gets on the ship. Oil rig explosion from 2010. And you have to make sure that the oil rig isn't leaking information oil to make sure there aren't any oil spills across the entire Gulf of Mexico. Very dangerous. Similarly, it's very dangerous when we have all of and then we interact with vanilla databases. This danger. You have your application, you have all these nice guarantees, and then you're tempted to write a query. Select users where location is equal to Chuck E. Cheese. There's an implicit leak here because you're capturing sensitive information to a vanilla database can now subvert all of your. And so you might say, well, why can't I just load my entire database and run load all of your data into memory? You have decades of optimizations of SQL databases. Practical. So what we want is to support when interacting with unmodified SQL databases. And what we want is to support this crazy model where we have through all database queries. So what we want is the semantics of this are something like faceted value, Chuck E. Cheese, or the city. We save it to a conceptual row in our database where we have some primary key. Then we want to be able to write queries that don't everything from users where location is Chuck E. Cheese, and then we want to so that we can make sure the policies follow the values through all the queries. So you might say, that's easy. We can store facets as or a new database for each label. Those are too expensive because they don't let us take advantage of existing and also they're very difficult to formalize. So the database was so we can extend our guarantees, but if we can't so we have relational mapping to map faceted values onto multiple. So as I said, support a uniform object representation. We have a faceted object representation and mediates faceted. So we take our conceptual row, primary key 1, A, and we can map this onto multiple rows with which facet we had. So we have this Jeeves key, all these facets together and says, hey, these all belong to the same value. We have another column, the which facet the row is for. The positive A label and the other values with the negative. Tested trees of facets by having just more rows. The cool thing here is now you can call and it'll select only the subset of rows that match. But as long as you do the facet bookkeeping appropriately, the results of the selection are only visible to the viewer. In coding, we can support a significant subset of making sure that we facet and refacet appropriately. So Jacqueline supports get, all, filter, even sort, using the SQL implementations and then refaceting appropriately. Facet bookkeeping, and we can't support some because that would. But the takeaway here, we can get this faceted executions through all our nice guarantees across the application and database. Well, this is great, but doesn't this really blow up? Because you have multiple values, you're branching on all these things all the time. Well, it turns out that with web applications, nice optimization we can do. Because as I said before, with the model view controller, there's a user. And so we can make the observation that the framework can often keep track of who the viewer is. It's usually the session database, so you don't know who it is. Sometimes you're sending email, so it's, especially for computationally intensive things, it's your session user. That as soon as we know who the viewer is, we throw away on the one, but we get still all of the nice guarantees. The interaction with the database, the early pruning optimization in our paper. We have, I'm not going to go into the details, but I will tell you what our highlights. So if you're familiar with information flow interference theorem, we have one, but it's different than traditional. How? So traditional non-interference says something. So if Emery can't see the secret location, but it should not make a difference to what he sees. Agnostic programming is that we're actually computing our labels from the program. The labels might themselves depend on sensitive values. This other theorem that says all executions where you can't see the high confidentiality. So if Emery, he can't tell that guest list from any other guest. So now, property that we're enforcing the policies correctly across. And the final question is, how does this work in practice? Crazy Python metaprogramming, we did some crazy, we implemented a web framework that we used to build a few small course manager, a health record manager, and a conference manager. The workshop had 23 users and 7 submissions. Bigger inputs. Reduces the number of lines of policy code we have to write. Obviously, also, it has reasonable overheads for a lot of the things. But first, before I get into that, let's do a quick demo in Jacqueline. All right. It's working. My virtual machine kind of. Oh, I only have 2 minutes left. Maybe we do the demo at the end. Make sure there's enough time to do everything else. All right. So for running times, we implemented another conference management system where we manually implemented the policy database and we looked at performance. So one thing we did, the profile for a single paper, increasing the number of total compare Jacqueline to Django. So it turns out that the very comparable. Jacqueline is actually a little bit faster than Django. Example. But basically, if you're showing a small amount of overheads are reasonable, often negligible. Then we did all of the papers in the database, and so we went up to 1,000. So what we found was there's a constant overhead. A small note is that this table is different in optimization, and we're in the process of redoing it. What's in our paper is 1.5. This is what you would get if you checked out our code now. Was all of the overheads are as a result of, and so we're in the process of getting rid of those. Just very reasonable, often negligible overheads. For everything else, there's a constant overhead that we're working on. You don't have to do this extra work. All right, so to summarize, programming with Jacqueline, the programmer specifies information functionality. There's an enhanced runtime that enforces the policies and database. And so can be practical. And some final words from the authors. Can factor out information flow policies, can enforce policies across the application and data. And finally, you can build realistic systems. And I think I have a very small number of seconds left, so let's like really all right, so long time to log in. Sorry, it's not my fault. It's and also sorry, I set it up before, but somehow show you a demo if you come up to me. But right now, I'll just like to say that it's incredibly exciting that the programs and the concerns they have are very different from the when they design the programming models that we're using today. All the advances that we've been making in programming tools makes models we should have for the future. I'm really excited to think about this, what we come up with in the next few years. Thank you.
So, Zhong Chao from Yale University. So, I'm curious, the database technique you introduced, would that make the database much bigger because you have to store these faceted values?
Yes. So right now we're storing facets in the database, and we are making the database much bigger, which is why when we measure the numbers, we looked at, well, if we're storing this extra information in the database, how does it affect the actions we want to do? And we found that, well, as long as we're not storing unreasonable amounts of data, it's fine. But we, in doing this, we realized that a lot of the time, if you're just returning undisclosed location, you don't actually need to store that value in the database. You can compute it lazily upon retrieval from the database. So that's one of the next things that we want to do.
Hi, Arjun, UMass Amherst. This is really cool work. I'm curious, have you thought about migrations and what happens when schemas change and things of that sort?
Yeah. So that's a really good question. And for migration, so the nice thing about this approach is that a lot of, the only thing you really need is this extra metadata to keep track of your facets. So if you want to take data that hasn't been faceted and add facets to it, you just have to add the appropriate metadata. And so for migrating that, you can just do that.
Thank you for great talk. I want to ask you about the possible extension of this work for side channel, prevention of side channel arises from time execution or memory consumption. Do you have idea or do you see any concept that this work can also prevent those kind of attacks or side channels?
So the programming model, there definitely can be extensions of it that encompass side channel attacks. That's not something we've looked at before. But the idea of executing multiple views of your program is a really nice abstraction for doing that, because you can essentially say, well, executing this should take the same time as executing that, and that abstraction is really nice. So this is definitely something that the abstraction we have can extend to.
Thank you.
Let me just remind everybody to give their name and affiliation.
Hi, Stephen Aus from TU Darmstadt. Just a question on how complex the policies can actually get. So think about e-voting. This is not like, as long as you're not able to see that piece of data, you shouldn't learn anything about the data, but you should learn, let's say, the count, but not who voted for whom. So you need some fairly complex sanitizers and policy on the sanitizers. Is that feasible with your approach?
Yeah, so a lot of policies that seem complex, as long as you can encode it in terms of, well, these are the fields and this is a function that protects it, then you should be able to do it. For sanitizers, that requires something else, because then you're tracking inputs and how they're flowing through the program instead of sensitive values and how they're flowing out.
Yeah, you can have a sanitizer on what comes from the data. This is not necessarily input. I mean, let's say, for instance, if you want to have a list of who won the election, right?
Yeah.
Then you're reading data from the database. Let's say it's simply stored like I voted for A and you voted for B.
I see,
then it's
yeah.
absolutely okay for me to see like there is 50-50, but it's not okay for me to see who voted for whom. So we need to sanitize that data through aggregation, for instance.
Yeah. So we have looked at, there's an extension of the work that I've only looked at a little bit, but basically policies for the default value that you use. So one way you can encode the sanitizer is instead of having the full secret value, you have some policy that talks about what the public value should look like. And so there's an extension of this work where you can add a policy language for that, which I believe is what you're talking about. We can talk more about this offline.
We should take this offline.
Yeah.
Thanks.
One last quick question.
Okay, so just very quick. So have you thought about extending this to probabilities, like assigning probabilities to the policies, and then doing the inference as you go?
Yeah, that would be a really interesting extension. If you're interested in that, we should talk. Because someone mentioned that this is like some machine learning approaches where you're just carrying around different views of different worlds. And so I think there are some really nice connections there.
So I'm going to jump in and ask one question. I hear there's some sort of party.
It's secret, Emery. You don't know about it yet. Oh.